Okay, so this is the serum dilution part where we're going to do the plating of the bacteria. So this is the spread plate. And so we use a galley rod, and then we have to ignite it and with some alcohol on it. So we dip it in alcohol and we'll stick it in the flame, and this will light. But we don't want it to be in the flame very long. We just want to ignite the alcohol, and that will burn off and kill the bacteria. And then we can just go and spread on the auger itself different directions. And so you can turn flame a quarter turn, another quarter turn, just go wall to wall. Make sure you're touching the wall. And then when you're done, you have to, just like before and after with the loop, you have to put this in here, sterilize it, flame it, and then once it burns out, give it 5 seconds, and then you can do the next drop. Okay, so we're going to do a little bit of a sequence here where we're going to put the drops on the auger first. If they don't take too long, they'll be still there, they won't soak in. And then we'll come back and galley rod them. So we can use one pipette, and it's all about conservation of materials in a microbiology lab. Whenever you can, you want to save the pipette, so, or save the resources. And so we can start at the 10 to the 8, and we can use the same pipette if we go backwards to 10 to the minus 7, because the 10 to the minus 8 compared to the 10 to the minus 7 dilutions has 10 times fewer bacteria in the 10 to the minus 8. And so anything that we bring over from the other one will not be significant. Okay? But if you went the other way from the concentrated on up, you know, even a fraction of a drop would be a significant amount of bacteria that you would add to the plate. So we want to go backwards, one pipette. Okay, here we go. And we're going to use rudder technique, aseptic technique. Okay, so I've laid out the plates. I'm gonna roll it. And I'm gonna do 3 drops. 1, 2, 3. And I can turn it back. Put this way back. 10 to the minus 8, we're going to do 10 to the minus 7 next. And I squirt it a few times to mix it up if I'm not going to use the full vortex. So then I'll go 1, 2, 3. Six. Okay, here's the 6. 3 drops. so what I did is I noticed contamination. There was some fluid on the outside of the tube, so I just treated it like the fluid came from inside the tube. And I'm going to get a new pipette. So it's all about being aware of your surroundings and making sure that nothing gets contaminated. Okay, so we got the 10 of the 5th now, those are done. Now we're going to go to 10 of the 4th. Three drops. Second. Okay. Now I need to dowel rod each one. Okay, alcohol, doesn't matter which one I'm going to do because I can. So I'm just going to help us get this, touch out. Actually, I'm going to touch out beyond, touch an area that doesn't have the liquid yet. And then I'm just going to rotate this, make sure I'm spreading it equally around. That one's done. Touch somewhere else first. Then we're going to go in and hockey stick everything. This is going. Touch somewhere else. Go into the liquid. Spread it around. So ideally, when we get done with these and these grow up overnight, 2 days, they will be 10 times the difference. So from one plate to the next, you should be 10 times different number of bacteria. so I keep the shield in front of my face, keep it from spitting into the bacteria and contaminating the surface. One final time. All right, so now I have everything plated. So the important thing to remember, anytime you're growing bacteria, once they're put on the plate, you have to incubate and then later on store them upside down. So we're going to flip it this way. And I'm double checking my order. 10 to the minus 4, 10 to the minus 5, 10 to the minus 6, 10 to the minus 7, 10 to the minus 8. You should always be checking. Even when I was doing the sequence of plates to do the dowel rod, I noticed that a couple were out of sequence, so I flipped them around, and so you saw that. But it's always important to be aware that things are where they're supposed to be. All right, so these are E. coli, so they'll go into the incubator at 37 degrees for 24 to 48 hours. So what we've done today is, first of all, we've done the stock bacteria here. We have no idea how many bacteria are in here. We're trying to figure that out. And so we did a dilution that was a half dilution each time. So half, fourth, 1/8, 1/16, 1/32. Okay, and so those we put in the spectrophotometer and measured it at absorbance of 600 nanometers. Up here we just finished the dilutions in step 1, so we took 1 milliliter of the stock, put it in 9 milliliters of saline blank, mixed it up, put 1 milliliter of that into the next blank tube, mixed it up, put 1 milliliter of that into the next blank tube, on and on till we had a 10 to the minus 8 dilution. And those were the 8 tubes that we just, actually we didn't plot the, let's see, 1, 2, 1, 2, 3, 4. Yeah, the 8 tubes that we put 3 drops or 1/10 of a milliliter on the plate. And then we're gonna, then we dowel rodded them, we spread them out, and then we're gonna let them grow, and then we'll count colonies. And next time we'll talk about how to pick the plate that we're gonna use and how to do the calculations, and then how to take that numbers that we get from the dilutions. So we'll basically get the number of colony forming units or bacteria in the original stock per milliliter, and then we'll correlate that and make a case that we can now make a graph from the spectrophotometry readings, so that in the future we do not have to do any dilutions, we don't have to do any spread plates, we just take our sample and we put it in the spectrophotometer, and then we use a graph that we've created in this experiment to determine the total number of cells per unit, per milliliter. Okay, that's it. This has been a little bit of a convoluted experiment, but we'll still try to tie it in and make sure everybody understands what the steps were and why we did them and what the outcome is. And believe me, you'll like this if you were actually doing this in person, which I hope you can later in the quarter. But this is going to save you so much time in future experiments, so you don't have to do the plates and you don't have to do the dilution tubes and you don't have to waste media and time. You can just put it in a spectrophotometer and figure out how many cells are there at any instant. As long as it's set at 600 nanometers for the wavelength and that you're using E. coli. It changes for other bacteria, so we'd have to do this experiment for other bacteria. Anyway, that's it for today. Talk to you guys later.